Okay, in this video we're going to look at determining vertical shifts for sine and cosine functions. So recall that when we talked about transforming functions, that we shift functions vertically by adding or subtracting a value from to or from the function itself. So in other words, we evaluate our function, our parent function, and then we either add or subtract a number after that. That causes a vertical shift in our graph. So for sine and cosine functions, the vertical shift becomes sine of x and then plus a value that could be positive or negative or 0, and y equals cosine of x and then plus a value that could be positive, negative, or 0. So again, notice that we don't have the parentheses around x plus the value of d here because it has to be done outside the function for vertical shifts, not inside. We'll see inside horizontal shifts in the next video. So example 3, determine the vertical shift for each of the following. We have part A, we have y equals sine of x and then plus 3. So just to give a quick demonstration, here's the sine of x, and here is our sine of x plus 3. So notice each point on the black graph, such as pi over 2 and 1, was shifted up 3 units on the purple graph. So take the 1 and add 3 to it. For this same value of x, we get 4. So our vertical shift is up 3 units. Part B, cosine of x minus 1. So here, for part B, let's highlight cosine of x. And then for part B, we have cosine of x minus 1 in purple. That is the red graph shifted down 1 unit. So again, here's 0, 1 on the original function, and on cosine of x minus 1, it's 0, 0, goes to the origin. So it took the red graph and shifted it down 1 unit. Part C, 2 sine x minus 4. So, okay, well, here's our sine graph, our parent function, and let's look at 2 times the sine of x minus 4. Well, as we can see, it did change the overall appearance because of the 2 out in front of the sine of x, vertically stretched it by a factor of 2. But if we look at our original x-intercepts here, 0, 0, and now we're at 0, negative 4. So it shifts the graph down 4 units. The 2 that's out in front is a vertical stretch. It does affect the amplitude, but in terms of vertical shifting, it does not. It's only what we're adding or subtracting at the end. So we're shifting down 4 units. Finally, part D, negative 0.5 times the cosine of x. So let's put cosine of x back up there, and then our negative 0.5 cosine of x. Well, in terms of transformations, there's nothing that we're actually adding or subtracting after the cosine of x. It does reflect it across the x-axis because of the negative, and it does compress it vertically by a factor of 2 compress it vertically by a factor of 2 because we're multiplying by a half. But in terms of shifting the graph up and down, it doesn't. So the vertical shift is either none, or you could say plus 0, which is shifting at 0 units. All right, so that about does it for this video. Thanks for watching, and I'll see you next time.